Hi, so our second unit is called Quadratic Expressions, and the first lesson is basically going to be a review of polynomials that you have learned in grade 9. So I'm going to walk you through some of the terms and terminology that you need to know for this unit, and we're going to do some practice problems. Alright, so first of all, a polynomial is basically an algebraic expression formed by adding and subtracting terms. And they're basically classified by the number of terms or its degree, and I'll show you what that means. So if I ask you for what type of a polynomial is, you're going to be basically classifying that with either the number of terms or its degree. But what does the degree of a polynomial mean? It is basically the greatest degree of any of its terms, and I'll again do an example. The degree of a term is basically the sum of the exponents on its variable within a term. A term basically consists of two things. There's a numerical coefficient and a variable. And sometimes you'll have an exponent on the variable, which is also part of that term. Alright, the different types of polynomials, and this is when you're classifying them with the number of terms. So you can have a monomial, which is either a number, a product of one or more variables, or the product of a number and or more variables. So for example, if I just had like a number, say 5, for example, that is a monomial because it's a number. You can have a product of one or more variables. I could also have something like xy. That is a monomial because it's a product of one or more variables. Or you can have a product of a number and or one or more variables. So for example, 2abc, this is also one term. And that term consists of a coefficient here along with the variables that are being multiplied with each other. A binomial is when you have two terms, and those two terms are separated by either a positive or minus sign, or so some or different signs. In this case, there's a plus sign right there which differentiates two of my terms. So when you have two terms, that is called a binomial. A trinomial, just the word says it, is three terms, and that is separated by two signs, so either positive or negative. So here I have two signs that separate three different terms. It's called a trinomial. And polynomial is when you have an expression that has more than three terms. So here, for example, I have four terms that is separated by three signs. So positive here, negative here, and a negative there. And that separates four of my terms. So that's called a polynomial. So let's do some examples of being able to classify our polynomials with the number of terms along with its degree. So for example, if I have 5, how many terms do you have? You only have one term here. And the type of polynomial that would be, since we're looking at it with a number of terms, this is going to be called monomial. Its degree, there's no variable here. So technically you can put a variable with an exponent of 0, because anything to the exponent of 0 is a 1. So here the degree is 0. And classifying the polynomial by its degree, it's basically it doesn't have any degree, so you can just say 0th degree function. Alright, so you have 3x here. The number of terms, again, this is one term because you have a product of a numerical coefficient along with this variable. So that's one term. The type of polynomial, in this case, since there's only one term, that's also a monomial. The degree, we're going to look at the highest exponent on the variable. So the exponent on this variable is 1. And this is a first degree function. Alright, here you have two terms, 4x and a 2. That's two terms. This is a binomial. The degree, we're going to look at the exponents and look at the highest exponent on the variables. In this case, is a 1. Again, that's also a first degree function. Next one, I have 1, 2, 3 terms, and that is a trinomial. Degree, look at the highest exponent. So the exponent here is a 2, and here it's a 1. The highest number is a 2, and that's a second degree function. And lastly, the example here is I have how many terms? 1, 2, 3, 4. 4 terms, that's known as a polynomial. So anything more than 3 terms is a polynomial. The degree, I'm going to look at the highest exponent. So here I have exponent of 3, a 2, and a 1. The highest exponent in one of my terms is a 3, and that's a third degree function. Alright, great. So more terminology coming along, and that is, terms of a polynomial is usually written in 2 different ways. The first way is called descending order. That's when you're writing your exponents from the highest exponent to the lowest exponent, so it's decreasing gradually as you go from left to right. Or you can write it as an ascending order. That's when you are writing your exponents from the lowest to highest. So as you go from left to right, you have a term that has the lowest exponent, and then as you go towards the right, you have a term that has the highest exponent. Okay? So here you have a highest exponent, lowest exponent, so it's descending order, it's decreasing, whereas ascending is basically it's increasing. Like terms are classified by 2 things. This is extremely important, and I need you guys to be able to understand how to collect like terms. Like terms are identified by 2 things. One is its variable. It must have the exact same variable. Along with that, the exponent on that variable must also be identical. Okay, so that's basically how to classify like terms, and we'll do an example from that. So here it is a simplified expression. Simplified expression basically means to collect your like terms either by subtracting or adding your like terms. So an example here is in brackets 2x squared plus 3x minus 5, and adding that expression with 7x squared minus 6x minus 2. So when you're going to do this question, the first thing to do is to get rid of your brackets. So in order for you to get rid of your brackets, you want to make sure that nothing is in front of the brackets. So in this case, there's only a 1, so I can go ahead and just drop the brackets. So I get 2x squared plus 3x minus 5. And here again, I only have 1 in front of the bracket, so I can just go ahead and drop the brackets. So that's plus 7x squared minus 6x minus 2. And collecting your like term means you must have the exact same variable along with the exact same exponent. So here I have x squared and x squared. I'm going to put them together. So that's 2x squared plus 7x squared. And I have the 3 and the minus 6x. I'm going to write them together. And then I have a negative 5, the negative 2, writing those 2 together. And let's go ahead and collect your like terms. Now you can go ahead and add and subtract your coefficients that have the exact same variable with the exponent, meaning they must be like terms. So here I have 2x squared plus 7x squared, that's 9x squared. 3x minus 6x is negative 3x. And negative 5 minus 2 is a negative 7. Just make sure if I can simplify that any further, and I cannot because they are not like terms. This is x squared and that's x. It's like comparing apples with bananas. So they're not the same. Alright, great. So let's go ahead and try another example. 4x squared plus 5ab, 4a squared plus 5ab minus 9b squared minus bracket 7a squared minus 6ab plus 2b squared. The first thing you want to do is get rid of the brackets. So look at what's in front of it. Since it's only a 1, a positive 1, I can just go ahead and drop the bracket. So that's going to be 4a squared plus 5ab minus 9b squared. In my second bracket, I actually have a negative 1. So I got to distribute that negative 1 inside my brackets. So negative 1 times 7a squared is a negative 7a squared. Negative 1 times negative 6ab is a positive 6ab. And negative 1 times 2b squared is a negative 2b squared. Alright, great. So now the brackets are out. We can go ahead and collect our like terms. So like terms again, the same variable with the same exponent. So here I have a squared and a squared. I'm going to join those 2 terms together. So that's 4a squared minus 7a squared. 5ab with 6ab. Put those 2 together. And then I have negative 9b squared minus 2b squared. Alright, let's collect our like terms. 4 squared minus 7a squared is a negative 3a squared. 5ab plus 6ab is 11ab. And then negative 9 minus 2 is a negative 11b squared. And that is my final answer because the other terms are, the terms that remain are not like terms, so I cannot collect them or simplify them any further. Alright, great. So now we're going to move on to some exponent laws. And exponent laws are very useful. I'm just going to extend this a little bit. Are extremely useful when you are multiplying your terms. So again, exponent laws are important when you're either multiplying, dividing, or dealing with negative exponents. Those laws are extremely important. So anytime you multiply with the same bases, you can go ahead and just add their exponents. So that's an m and n, and here you can just write it as one base, m plus n. When you're dividing, you can subtract exponents, the top exponent minus the bottom exponent. When you have an exponent in the bracket and an exponent outside the bracket, you can multiply the two, call it product of a product. So mn. And here you have two things that are multiplying with each other with an exponent outside. That exponent applies to every variable inside the bracket. So you can rewrite this as x to the power of m and y to the power of m. Similarly, when you're dividing two terms with an exponent outside, that exponent applies to every variable inside the bracket. So here will be x to the power of n over y to the power of n. Any negative exponent, you can take its reciprocal of that term and make it a positive. So if we have x over 1, you can flip this to become 1 over x to the power of n. Again, if you have a coefficient with a negative exponent, you flip your coefficient, so you take its reciprocal, and you're going to change that negative exponent to a positive exponent. And lastly, anything to the power of 0 is equal to 1. So those are exponent laws. Let's go ahead and apply them to an example. So here I have a term, 2x, that is being multiplied by a trinomial, so 5x squared minus 3x plus 1, and I have to simplify that. So when you're simplifying, you have to distribute this 2x inside the brackets. So 2x times 5x squared. Let's multiply the numbers as it is first. So 2 times 5 is 10. And when you multiply the letters, so in this case, I have an x and x squared. So the exact same letters, all I have to do is add their exponents. So it'll be 1 plus 2 is 3. So it's x to the power of 3. We're going to do the same thing when 2x gets multiplied by negative 3x. You multiply the numbers as usual. So 2 times negative 3 is a negative 6. And I have one x here and another x there. So when I multiply them, they double. So it becomes x squared. In other words, you're just adding the exponents. So 1 plus 1 is 2. And then 2x times 1 is 2x. So that's how you're going to use exponent laws. When you're multiplying with the same base, you can add your exponents. Let's try another example here. So negative 3x squared is going to get multiplied by 2x squared along with a positive 5x and a negative 3. So let's multiply numbers as usual, as you would. So negative 3 times 2 is a negative 6. I have x squared times x squared. They're the same basis. So I'm going to add my exponents. 2 plus 2 is a 4. So x to the power of 4. Negative 3 times 5 is a negative 15. I have x squared and x. I'm going to add their exponents. That's 2 and 1. That's 3. The negative 3 times negative 3 is a positive 9. I don't have any x's there, so I'm just going to copy down the x's that I had originally. X squared. Alright, let's do the next one. So I have ax gets multiplied by bx, gets multiplied by negative cy, as well as d. So a times b is ab, and I have x and x, so that means same basis, and add their exponents, it's x squared. Here I have a times c, which is, so negative c is negative ac, and I have x and y, they're not the same basis, so let's write them as xy. A times d, so ax times d is just basically ax d. There's no like terms here, because they're all different variables with different exponents. Alright, And the last thing that we're going to basically touch upon, we'll continue this tomorrow, is factors. And factors are basically any numbers that go into it. So for example, if I want to figure out the factors of 12, I got to figure out all the numbers that go into 12. So we're going to start off by just listing the numbers together and see which ones go into 12. So 1 goes into anything. 2 goes into 12 because 2 times 6 is 12. 3 goes into 12 evenly. 4 goes into 12. 5 does not go into 12. 6 goes into 12. 7 does not. Neither does 8. Neither does 9. Not 10. Not 11. And 12 goes into itself as well. Okay. You cannot have any factors of 12 that are greater than 12. So it's a number that go into it, not multiples of it. So factors of 18, we're going to go ahead and list the numbers out again. 1 goes into anything. 2 also goes into 18 because 2 times 9 is 18. 3 goes into 18. 4 does not because 4 times something will not give you 18. It does not go into 18 evenly. 5 does not. 6 does. 6 times 3 is 18. 7 does not. Neither does 8. 9 goes into it. Not 10, not 11, not 12, not 13, not 14, not 15, not 16, not 17, and 18 will. So the greatest common factor between 12 and 18, so I basically look at what are the common factors here. Well, 1 is common, 2 is common, 3 is common, 4 is not, but 6 is common, and nothing else. So the highest factor that's common amongst both is 6. So 6 is the greatest common factor. Okay, and that's it for today. Your homework is the following, which we're going to do in class. If you want to get a head start, please do so.